In this video, we're going to focus on questions, possible questions on set and set theory. We are given a question here, class. They said, let's set A equal to 0, 1, minus 3, and B equal to S such that S squared plus S minus 2S is equal to 0. Then we are asked to find A intersection B. Now, this particular representation here, that is this one here, is called roster or listing method. Please take note. It's called roster or listing method because the elements are given. You don't need to solve to get the elements. While this one here is called builder's method. That means you have to interpret or you have to solve to get the elements. Please take note. So let's solve this question here, class. This solution here. Okay, the element of A is listed already. That is 0, 1, minus 3. So the element of B, we can get the element of B when we solve this quadratic equation here. That is S squared plus S minus 2S equal to 0. So class, we can solve this using factorization method or using formula method or completing the square method. But in an exam situation here, we can just use our calculator to do this. So how do we use calculator to solve this here? It's very simple here. Remember, I told you guys in calculator shortcut that whenever I want to solve any topic, you have to put your calculator in the mode of that topic. So you press this mode here. So this is equation 5. You press 5. So you see something that looks like quadratic, that is as squared plus bs plus equal to 0. That is 3. So this is AB. So I have to impute my ABC. So my ABC are this. If you compare this quadratic here, given to us here, that is s squared. If you compare this s squared plus s minus 2 equal to 0 with this standard form here, that is as squared plus bs plus c. Okay, now this is s squared. What's at the front of s squared is a, so there's an invisible one here. This is bs. What's at the front of this is s here. What's at the quotient of s here is b. So this is s here. The quotient of s here is 1 here. Please take note. This is c and this is our c here. So our a will be equal to 1, our b will be equal to 1, and our c will be equal to minus 2. You don't say 2, you say minus 2. Whenever it is minus, you take both the sign and the value. So let's impute this here. A is 1, you put 1 equal to. B is 1, you put 1. C is minus 2. Please take note. Finally, equal to. So our first S is equal to 1. The second S is equal to minus 2. So the set of B here is 1 and minus 2. Please take note. So this is how we solve this here. Now, it might not be quadratic equation. It might be inequality. All you have to, all you have to do there is to interpret the inequality and list out the elements. Okay. Now let's solve this here. We are asked to find A. We are asked to find A. We are asked to find A intersection B. And the element of A is 0, 1, minus 3. Intersection B is 1, minus 2. Now, what is A intersection B? Now, intersection of a set simply means the element that is common in A and also common in B. So, what are the elements that is common here and also common here? This element is 1. Please take note. So, class, this is my answer here. And this particular set can also be called a singleton set. That is any set that has only one element. It's a singleton set, okay? So this is my answer here. Please take note. Let's solve the next question here to understand more on sets. Please write power set. Before we solve a question here on power set here, Let's know what power set is. Please write. Power set is a subset of a set. Power set is a subset of a set. Okay, for us to know most of the set under that set, we call it power. We use the formula for power set. So the power set of a set can be represented as P is equal to 2 raised to the power of n, where P represents the power set and n represent the number of elements. P represent power set, n represent number of elements. Okay. Now let's solve a question here, class. Question 1 here. We are given a question here. They said if set A is equal to phi omega beta, find the subset of the set A. So let's solve this question here, class. Solution. We are given A is equal to set of phi omega beta, and we're asked to find the subset of set A. Remember, to find the subset of a set here, we use power set. So the power set of this set here is given as, of a set is given as 2 raised to the power of n, and m represents the number of elements. Please take note. Okay, now the number of elements here in this set is 1 2 3 is 3. So our m here is equal to 3. So the power set here will be equal to 2 raised to the power of 3, and 2 raised to the power of 3 does not mean 2 times 3. 2 raised to the power of 3 simply means repeat 2 into 3 places, and my answer here is 8. Please take note of this. Okay, so the power set, the subset of this set here will be 8. Let's consider the next here. Please write cardinality of a set. Cardinality of a set. Before we solve a question here on cardinality of a set here, let's know what cardinality of a set is. Please write. Cardinality of a set is the element in a set. Cardinality of a set is the element in a set. So the number of elements or the number of members in a set is known as cardinality of a set. We can denote this as, if I have set A, the cardinality of A is number of elements in A. Please take note of this. So this is how we denote the cardinality of a set. If I have set B, to know the number of elements in B is called cardinality of a set B. Okay. Now let's solve question 1 here to understand what cardinality of a set is. Okay. Question 1, please. Right, we are given a question here. They said, given that set B is equal to 1, 2, 3, 4, find n of B, that is the number of elements in B. So let's solve this here, class. So the number of elements in B simply represent cardinality of set B. Let's count the element here. This is 1, 2, 3, 4. So the members in this set here is 4. So this is my answer. Please take notes.